Hello and welcome to video 14 under the endocrine system for anatomy and physiology. We are on diagram 14 in our note packet, and this is the adrenal medulla response. And this one is sometimes called the fight, flight, or freeze response. So in this diagram, our first part of this is going to be our stimuli. So this could be an increase in stress. So if this was the fight or flight, maybe something jumps out at you and scares you. This can cause this response. So an increase in some kind of stress. Physical activity. So exercise can cause the release of this. And so can low blood glucose levels. So any one of these or a combination of them can cause an effect. So right here is where it's going to originate, and this is going to be the hypothalamus. So this one really does not involve the pituitary at all. So the first step that we have here is one or two or all of these stimuli causes the hypothalamus to generate action potentials, activating a sympathetic nerve impulse or impulses. So we can generate more action potentials. The higher the frequency, the bigger the response, as we have seen earlier in videos. So number two is down here. So we started action potential. It is going to come down through the spinal cord. And we are going to have the action potential, or this spinal cord, we're going to have a synapse, and then we're going to have a sympathetic nerve fiber here. And it is going to end in the medulla or medulla of the adrenal gland. So this is the adrenal gland. So number two, the APs travel through the sympathetic, I just spelled that wrong. Through the sympathetic nerve to the adrenal medulla, which secrete epinephrine and norepinephrine into the blood. And then we're going to have number three. Number three is the hormones travel to target tissues and cause an effect. There are a lot of different target tissues for this. And over here on the side, we're going to list some of the major responses to epinephrine and norepinephrine. So the first one is we increase glucose release from the liver. Remember, the liver stores glycogen, which can be easily broken down and give us glucose, so we have a store of that. So low blood glucose levels, we need more glucose, and we're going to see that other things are going to rely on that glucose level. We also increase fatty acid release from adipose tissue. So we end up releasing these fatty acids, which then can be converted into glucose, so another source of glucose. We increase the heart rate. By doing that, we get more oxygen to muscles, and we get these hormones traveling around the body a little bit faster. We decrease blood flow to internal organs. And these are the organs that are not responsible for any of these responses. So like the stomach, the small intestine, the large intestine, those processes the digestion slow. So we decrease the blood flow and we decrease the organ function. So those visceral organs do not need to work. The stomach really doesn't need to work real well because they work best when we're at rest, not when we have an increase in physical activity or a stressful situation. It increases blood pressure. And we increase blood flow to skeletal muscles and the heart. So the heart itself needs blood, so we increase the blood flow, but we also increase blood flow to skeletal muscle, which in turn, with the increased heart rate and increased blood pressure and availability of glucose, we really increase the metabolic rate of the muscles, which helps us get away or fight or help us with the increased physical activity. So this is going to continue until the stimuli are gone and we don't need any more of this. So under sympathetic nervous system, this is a rather fast response. That is it for video 13. Thank you.